So hello everyone and welcome back to a brand new video, and in this video I'll be covering problem E from Atcoder round 275, and this is kind of an experimental video to see the kind of response that Atcoder videos get, and if this video gets a good response I will start covering Atcoder contests in the future. So be sure to leave a like and do comment if you guys want me to cover Atcoder more, right? So let's start with the problem. Before we move on to the solution, I want to take a small break and tell you guys about Newton School's Premier Coding Contest. So as all of you guys love CP and all of you guys love to code, this is a great opportunity to show off your coding skills and also win some cash prizes. There are prizes worth rupees 30,000, and along with this you can also win some free coding courses or also grab some internship opportunities, right? So for this reason only, Newton School organizes this contest every month on a global scale. So you can also benchmark yourself where you are lacking or where you are standing compared to other students. So this month it will be on 27th October. It will be around 2.5 hours starting from 9 p.m. and it is absolutely free to sign up for. So there will be a link down below. So do check out that link and sign up for the contest for absolutely free. Yeah. So let's move on to the solution now. So in the problem, we have been given a strip made up of n+1 cells where n can be up to 1000. And the strip is something like this, starting from index 0. So we have 0, 1, 2, 3, 4, so on up to n. So this is a strip made up of n+1 cells, right? Initially we are at the 0th cell, so initially we are here. Along with this, we have been given a m face die where faces are numbered from 1, 2, 3, so on up to m. So we have an m face die where faces are numbered from 1 up to m. Also, this is a fair die, so there is an equal chance of rolling any face. So the probability of rolling any face is equal to 1 by m, right? So initially we are at the 0th cell. So we will roll the die, and whatever number comes up, we will move that many number of blocks to the right side. For example, if I roll the die and let's say number 3 comes up, so then I will move 3 cells to the right. So I will move from 0, 1, 2 and 3. So I will land at now cell 3. I will keep rolling the die until I reach cell n, right? So I will keep rolling the die until I reach cell n. So given this setup, you have to find the probability that we can reach cell n in less than equal to k moves, right? So that is the problem. So given the setup, find the probability that we can reach cell n in less than equal to k moves. Also, there might be a case that when the number rolling on your die might be more than your strip length. For example, let's say your n is equal to 4, right? And your strip is something like this: 0, 1, 2, 3 and 4. Let's say you roll the die. Initially you are on cell 0. Let's say you roll a 3, then you will move 3 cells to the right. So you will move 0, 1, 2 and 3. So you will reach cell 3. Let's say you roll the die again and you get number 4 now. But if you see, there are not 4 moves to the right. You cannot move 4 cells to the right. So you will move excessive move. You will take the leftover moves and you will move these move to the left. For example, now we have to move 4 moves here. So I am able to move just 1 move, right? So I will go from 3 to 4. Now I have 3 leftover moves. I have 3 leftover moves. So I will just make these move to the left. So I will go from 4 and I will make these move to the left. So I will go from 4 to 3 to 2 to 1, right? So my cursor will now go to 1. That is how we handle leftover moves, right? So whenever your move will exceed the strip length, you will make leftover moves to the left side, right? So that is the entire setup. So given this, now you have to find the probability that we will reach cell n in less than equal to k moves. Now let's see how we can solve this. So we want to find the probability of reaching cell n in less than equal to k moves. But I can break this down, or I can rephrase this as multiple probabilities, right? I can write this as find the probability of reaching cell n in exactly one move, in exactly two moves, plus in exactly three moves, and so on up to in exactly k moves. And that is the same thing, right? If you want to find the probability of reaching cell n in less than equal to k moves, you can just break this down into k parts and find every probability individually. So I will find probability of reaching cell n in exactly one move, in two moves, three moves, and so on up to k moves, and I will just add them all up. So now the main concern is, why am I doing so? I am doing so because doing so will reduce the problem into a very well-known problem, right? This is a very well-known problem. How so? So if you think about this, finding the probability of reaching cell n in exactly k moves if you try to draw this out, you will see that we have a strip 0, 1, 2, 3, so on up to n, right? We are initially here, we are rolling the die k times, and every time we will just keep adding the number that we get on the die. So we will just add the number that we get on the die. So isn't this the same thing as saying find the number of ways to make sum n if you roll the die k times? That is the same thing, right? Because you are just adding the number that you get on the die until you reach n. So that is the same thing as saying find the number of ways that you can reach sum n if you roll a die k times. Ignore the rebound case for now, ignore the case where you can rebound, but in general sense, you can say that the problem is very similar to finding the number of ways that you can make sum n if you roll the die k times. So this problem is very similar or equivalent to finding the number of ways to make sum n in k die rolls. And this is a very well-known DP problem, right? You can also find this on CSCS, I think. This is a very well-known DP problem. So now we know that we can somehow define a DP state and use that to solve this problem. So now let's try to see how we can define our DP. So I will define my DP as DP of ij, where DP of ij defines probability of reaching cell I in exactly j moves, right? So that will be my DP definition. So my final answer will be how much? My final answer is reaching cell n in less than equal to k moves. So this is just equal to DP of n1, that is if I reach cell n in exactly one move, plus DP of n2 if I reach cell n in exactly two moves, and so on up to DP of nk. So that will be my final answer. So now the main concern is, how do I compute DP of ij? So I have to find the transitions for DP of ij now. If in my current step I am at DP of ij, it means I am at some index I and number of rows have been equal to j, right? So in my previous step, or you can say what would be my last step, right? So in my last step, I must have rolled the die. And I must have gotten some value from 1, 2, 3, so on up to n. I must have gotten one of these values, right? And the probability of getting any of these values is 1 by m, right? So I must have gotten one of these values. So previously, in my previous step, if this is my current step, in my previous step, I must be at some index I dash, right? And the number of rows will be j minus 1, right? Because after applying just one role, I am reaching number of roles equal to j. So in my previous step, number of roles will be j minus 1. So I will be at some index I dash. I will be having number of roles as j minus 1. And I will be applying one of these roles, right? And after applying one of these roles, I will reach index I. So I have to compute my transition for every of these rows, and for every role I have to find my corresponding index I dash, right? So that will be my transitions. So if I have to write this as loop, I will say for every role value from 1 to m, compute corresponding index I dash, right? For example, if my strip is something like this, right? Now let's say I want to compute my value I dash for, let's say, dice value 5, right? Then let's say I am at index I here, then my I dash will be either on this side, it is 5 steps to the left, right? 5 steps to the left, right? Because after applying 5, I will reach I from index I dash, or either I dash will be somewhere on the right side. After applying 5, I will first go to the right side and then rebound back, right? So I will find the corresponding values of I dash. Either I dash will lie on the left side. If it lies on the left side, my value will be I dash, I minus face value. And if it is lying on the right side, I will just apply mathematical formula for that as well, right? So for every face value from 1 to m, I will find the corresponding I dash value, and my dp of ij, I will just add to that. So my dp of ij will be dp of ij plus the probability of rolling this face. The probability of rolling this face is 1 by m. So 1 by m into dp of I dash and j minus 1. Right? So that will be my dp transitions, and that is the entire solution. So I will just write the transitions once again, so you guys can be clear. So for every face value, or you can say role value from 1 to m, I will compute I dash, right? And my dp of ij will be equal to dp of ij plus dp of I dash and j minus 1, right? And how do I compute I dash? Let's say your face value is equal to x. Your face value is equal to x, right? Then there will be two cases. Either your I dash lies on the left side. So if your I dash lies on the left side, so if your I is here and if your face value is x, that means after rolling die equal to x, you reached I. So your I dash will be just how much? Your I dash will be equal to I minus x, right? And the second case is when you rebound. So when your I dash lies on the right side. So in that case, if your I is here, if your gap on this side is equal to y, then your I dash will be how much? Because in x, your y moves will be wasted in rebounding, right? So you only have, so your leftover moves are how much? Your leftover moves are just x minus y, right? So your I dash will be how much? Your I dash will be n minus x minus y, right? You will take x minus moves to move this side, and then you will take y moves to move this side. So in total you will take how many moves? You will take x minus y plus y. In total you will take x moves, right? So if your difference of I from n is equal to y and your face value is equal to x, then your I dash will be how much? Your I dash will be equal to n minus x minus y, where x minus y is the number of leftover moves. And using this, you can find I dash, and then you can just put I dash here, and you already know the value of dp I dash j minus 1, and you can use that to compute dp of ij. And in the end, your answer will be how much? Your answer will be just sum of dp n1, dp n2 up to dp nk. And if you guys want to see the code for this, here is the code. I will define a dp. My dp of 0, 0 is equal to 1. That is the probability that I am at index 0 at 0 moves is 1, right? Because that is absolute. That is my base case. So dp of 0, 0 is equal to 1, and dp of 1, 0 for every other index is 0. Then I will go over every value from 1 to k, and I will compute dp of ni for every I from 1 to k, and I will add them. And that will be my final answer. And how do I compute this? So if you want to see, here is my recursive dp. So I will check if I already know the value of dp index moves, I will return that. Otherwise, I will try to compute the value. So I will go into my loops. So for every face value from 1 to m, I will check if my I dash lies on the left side. So this is the loop when I dash lies on the left side. This is the case when I dash lies on the right side. So for every face value from 1 to m, if I dash lies on the left side, I will check my index minus I is more than or equal to 0. I will then just do answer plus equal to recursion, index minus 1 and moves minus 1. So this is basically this part, right? So I am just computing dp of ij is equal to dp of ij plus dp of I dash j minus 1. Also here there will be 1 by m into dp of I dash j minus 1, right? So this is just dp of I dash j minus 1 into 1 by m. Similarly, if my I dash lies on the right side, I will compute the leftover moves. So here my I dash is how much? My I dash is n minus leftover moves. So this is dp of I dash into j minus 1 into dp of 1 by m, right? And in the end, I can just return dp of index moves, and that will be the entire solution. So if you guys have some doubts, feel free to join my Discord server and leave a doubt there. I'll be more than happy to answer them. Yeah, that is it for this video, and I will see you guys in the next one. Bye bye.